Hello world, this is Coder's Cove and welcome to a new video. TypeScript is a superset of JavaScript. Think of it like JavaScript with superpowers. It's a very complex and not at all fun addition in the beginning, but once you learn it well and add it to your toolbox, you'll wonder how you've ever lived without it. It allows JavaScript to be statically typed, thus cutting down on a lot of bugs in development, which would have made it to production environment, thus making the code base more robust and easier to maintain. Aside from that, TypeScript enables richer development environments and easier experience. IDEs like Sublime and VS Code, especially VS Code, provide better suggestions, more complete IntelliSense, cleaner error checking, as in there's more of them, and help, all because of the additional type information. It helps utilities and tools analyze your code more deeply, leading to a higher code quality. And the best part is, it's completely compatible with JavaScript, making it deployable wherever JavaScript runs. It's an open source project which has gained widespread adoption because of all the aforementioned reasons. In summary, a complete banger, or an absolute atrocity. Awful and sucky from the onset, but quite amazing once you get used to the access colons and random types in the middle of a line of code. Alright, let's get down to it. Unlike JavaScript, TypeScript does not come built into browsers or out of the box after installing Node. However, it does work with Node and NPM, and there's a special little package which takes care of all of our TypeScript needs. Simply open up the terminal or the command prompt like this and type npm install, or I for shorthand, -- global or -g for shorthand, and the name of the package. It's called TypeScript, obviously, and hit enter. After running for a while, this command will install TypeScript as a global package on your system. That way we don't have to install it per project locally. After the script finishes, we'll simply run tsc here, -- version, hit enter to verify the installation. If it actually gives the number, like 5.4.2 in my case, it means that it was successfully installed. Now let's go to the IDE and pick it up from there. Now that we're in VS Code, I'll simply create a file here and name it index.ts. I've written some JavaScript code and I'll paste it here, just to get a feel for it. Remember, all valid JavaScript code is also valid TypeScript code, and we see no errors. However, if we want to run the file, we can open up the terminal here with control backtick and run it with Node, and it'll work just fine without a hitch. But if we wanted to execute the code in the browser, which is usually where the majority of JavaScript goes, it simply won't do. For example, I have an index.html file with, and I'll link the TypeScript file here. I'll open it with live server. I'll drag it over here, and if I open the console, we get an error in the console saying the video is in a bad format for some reason, and thus we see TypeScript won't work on the browser. So we'll have to compile it into JavaScript, and to do that we'll use the command we've used so far, so tsc, then the name of the file, it'll be index.ts, and then we'll have to do a flag, that's what it's called, so --out file, and the name of the JavaScript file we want to have. I'll just call it out.js, hit enter, and it compiled here. Don't worry about the errors right now, that's because we have this JavaScript file opened up. If I close it, everything goes away. But if we just wanted the files to have the same name with a different format, I'll just do tsc index.ts, and we don't have to put the name of the out file. It'll simply generate it in the file of the same name. And now if we change the format to .js over here and open up with the live server, come over here, open it in the console, we see no errors, everything works as expected. If we want to recompile the JavaScript file every time we save, we can simply tack on the -w flag, which stands for watch. So tsc index.ts -w, and this will open the compiler in watch mode. It'll continuously check the differences between our files on every save, and it will change the JavaScript file when necessary. If there are no errors, we'll just see something like this. So if I just take off these two lines and save, it'll simply re-execute. And if we open up the index.js file, we just have the declarations as here in the TypeScript. I return this. As we can see, everything's back. So that's working. Whenever we create a variable and assign it a value, it is automatically assigned a type as well. Well, in TypeScript at least. So if I write let x equals 15, the variable x will immediately be assigned the type of number, and I can confirm that by simply hovering over the variable name, and as we can see it here. Now if I try to change this value to a different number, it'll work perfectly fine. But for example, if I want to change the variable value to a different type, like string, over here, it simply won't work. The compiler throws an error and it says type string is not assignable to type number. It will always throw an error, and so will the compilation tool. I still have it running, and if I save right now, I'm getting an error here. Not only am I getting the error, but also the exact line of code and the starting position and the position of the error, so I can immediately see where it is and fix it from the get-go. But let's write our first type now to make sure the error goes away. And to do that, we will type this variable with the dynamic type, as it's known. So come over here, type colon, and write any. This will get rid of the error, but at the same time, all the safety is off at this point, and we're basically writing JavaScript in a fancy format. Now there are a couple of different types of variables, well, primitive types of variables, those being string over here. Then we have the number, as we've seen so far over here. Also Boolean, if we hover over here. And the other primitive values are null, undefined, and big int for big integer. While using these, we don't have to write a type when we initialize our variables, because they're inferred automatically. We generally never have to type variables when creating them at all, but there are a couple of special cases where it might be useful, and those would be objects and arrays. When it comes to arrays, the types of values we initialize them with will be the only types of values they will accept in the future. For example, if we have this array of numbers 1, 2, 3, 4, and we hover over the variable name, we see that it is an array which accepts numbers only. So for example, if I want to push a boolean value here, it will not be allowed because it's not assignable to the parameter of type number, as it says. But if I, let's say for example, change number 4 here to false, now the error goes away because since the array was initialized with numbers and booleans, it'll accept both. Same if I change this number 2 here to a string. Not only will it accept numbers and booleans, but string values as well here. But if I initialize an empty array, for example, and hover over it, oh, let's get rid of this. So it'll give me the type of never. In TypeScript, this represents values that will never occur. Adding anything to the array will produce an error. For example, array.push number 1 throws an error. Therefore, we must type our own array on the same line as we initialized it, because nothing will work here. So if I add a number here, I can simply push numbers. But if I add, for example, any, this will again behave like a regular JavaScript array, accepting any and every value. Now, another kind of array in TypeScript is called a tuple. It's basically an array with 2 different quirks. It has a fixed number of elements, all of whose types are already known beforehand. Now, to create a tuple, it's basically like creating an array, except we type everything immediately. So it's like this, colon, the types here. Let's just say it'll have 2 members. One of them will be a string, another will be a number. And this is basically it for tuples, but they aren't extremely, well, useful in this regard because, again, they're fixed and all of their values are known. Objects, on the other hand, are a bit more different. There is a type called object in JavaScript, but it does nothing except state that the value is not a primitive or a boolean string or a number. In other words, when we instantiate an empty object, it'll never have the type of object, but rather empty braces, and I'll demonstrate this here with this little variable. These empty braces simply don't provide enough information, but if we add, for example, key value pairs inside of the object here, the type will change. For example, the type will state that it's an object with keys on one hand and types of variables in another. For example, if I say name Peter and hover over the object, it will say that the object has a property name with a type of string. While we can just hover over an object and see its types directly like this from here, the truth is in some cases that's just not enough, and we might need to create a separate variable just to keep track of the structures of objects and their according type declarations. Well, we can do that with the keyword type, which is basically like a variable that keeps track of all the types in a certain structure. So for example, I'll call this type object type, and I'll assign it that it has the name with the value of string, the age with the value of number, and job string again. And this type can now be used like we've typed this array. Simply put a colon and the name of this type, and it'll be applied to the said variable, or in our case here, object. So if I add a colon here and write object type, well, first of all we get an error because some of the properties are missing. But if I add them, example 35, if I add them like this, there are no errors. This is actually a valid type, and it is one of the basic building blocks in TypeScript, so to say. Creating types and adding them to variables can go a long way to reducing the numbers of bugs present in the code, both in prod and development as well. But this was all way too easy for now. We've only ever been using synchronous values, which we've written, most of them primitive. But when working on large applications with lots of moving parts, the data types are usually not as clear-cut as everything we've seen up until now. It generally becomes difficult and sometimes near impossible to figure out what's going on. Some of the properties are optional, some are always required, some are basically non-existent because they've been omitted by something else. In some cases, some properties that are present actually have to be awaited from other promises in some asynchronous code, for example an API call. But luckily TypeScript has us covered with loads of its utility types, or helpers if you will. Utility types are here to give TypeScript some extra power. They facilitate common type transformations and are available globally. There are a lot, and I will link the TypeScript organization in the description below, where you can go and have a closer look for yourself, but I will only talk about a few of them. Starting off with the asynchronous operations. Awaited is meant to model promises and asynchronous code execution. It's a wrapper type, in a sense that it wraps around another type, which it will resolve to once the action is completed. This is usually the result of an API call, most of which use promises. And I believe that instead of just having awaited here, we can also use the promise keyword as well, though the difference between that one is that that one will resolve to a promise, whereas awaited resolves to a value. So that's the one big difference there. Another wrapper type that is particularly useful is the partial wrapper type. What partial does is it simply sets all the properties of an object to optional or nullable. And this utility returns a type that represents all possible subsets of a given type. Like earlier, we saw an error with this object and object type when we had to add both the age and the job properties here. I'll remove them and simply wrap the object type around partial, and suddenly the error is gone. Because if we wrap around this, we'll see that all of its properties are optional. It can either be a string or an undefined, and this is perfectly fine for this kind of type. Its antonym, or the complete polar opposite, would be required, which is yet another wrapper type. Required constructs a type where all of its properties are set to required. So if I just wrap this object around with required, it'll start throwing me an error saying that I'm missing some properties like X and Y. But once I add this, it's completely fine, the error goes away. Obviously, if we remove the required, nothing is ever needed here, but this just goes to show you that some types can enforce rules more strictly than the others. The read-only type constructs a type with all of its properties set to read-only. Those properties cannot be reassigned or their values changed. This is a useful type to use in tandem when making API calls with awaited, because we don't necessarily want to change the return value of the API call, and most of the modification will be done in state instead when on the front end, and various different database tools while working on the server side. Moving on, the record type constructs an object type whose property keys are set to a certain type, as well as its property values. If I were to type an object with the depth of 1, meaning no other nested objects inside, this is the utility I would definitely be using. As a bonus, it can be assigned to an empty object and still give no errors, meaning we're good to go, and we can worry about state management at a later point in time. For example, I would type a general object like this, string any, meaning that keys would be of a type string, while values would be of a type any. In a sense, this is basically the default way objects are handled both in JavaScript or TypeScript, or it certainly seems that way. The utility type pick constructs a type by picking the set of properties or keys from a certain object or a data structure, and we can see it in action here. So what's happening here is that we're awaiting this to resolve to a value back from when we had this API call, and from the type, where is it, type to do, which is here, this one with these values, none of which are optional, by the way, we're picking the user ID and the title. Omit, its counterpart, works the exact opposite, where we simply declare, well, once again, resolving to a value from an API call. And unlike pick, we declare what we want to omit or strip away from our data type, so that we would get everything except for that here. Again, it's the exact opposite of pick. These and many more utilities are simply a complementary courtesy of the TypeScript community, and as stated previously, I will link them in the description below. Feel free to peruse the utility types at your own leisure and pleasure.